us now discuss the second application. For example, friction. The second example is, let us take power screw. The power screw example, what really is, there is a load W. When we try to, and this one is connected with a lever which is having distance A, and let us say we have to apply load P to raise this load. So how we do it? So let us say we are having kind of system. Okay, so this way, let us say we are having screws like this. And the threads can be single thread or double screw thread. Now, since we have to apply a load P over here, it means that we have to apply some moment. Okay. So if we want to connect this moment M with this load that we are applying, that can be written as P times A. A is the arm length of this particular. And let us assume the radius of this particular the pitch of this thread is P. Now we have to find out the relationship of the moment that is being applied to raise the load W, which is acting. To solve this kind of problem, we have to consider the friction, because when you raise the load and you are rotating it, what really happens, it has to overcome the friction between your object and the screw thread. So if we try to look at, like if we take a case of, let's take a case of one full rotation. In this case, we can assume that point A this point A raised to point B. When it is going up, you can say that the point this will become point B. Okay. So in one full rotation, the radius of this particular thing is given as R. Now if it is a double, if it is single screw thread system, for single screw thread, that because of one full rotation, the vertical distance this particular object will cover will be equals to L, and for this case it is same as the pitch. Now for the double screw thread system, we will see that this L becomes 2P, and this is nothing but what is this L? This is the vertical displacement. Vertical displacement in this direction. And similarly, if you go to single, double, and three thread system, three screw thread system. In this case, this will become 3, and for n, this will become n times 3. Okay, but how do you describe all this kind of system? In the single thread system, you will see that, like you have threads like this. This is how it forms. So in this case, you will see that in the single case, in one full rotation, this point will join to the immediate thread at the end of this. Okay, this is the case of single. It means that your L will become P. Now, if you take double thread system, what will happen? This one full rotation points will go and join this. It means that the one full rotation you are having L is equal to 2. Similarly, for the 3 case, you will see that it can go to even the 3 case. You can see that this point. So your L over here becomes 3. So this is how you differentiate the different thread screws, and the influence of these single, double, and tertiary kind of thread will be your vertical displacement will be at times the pitch of the thread. Now, how it really makes sense? So we were trying to draw the ability of this particular point. So let us say in one full rotation this reaches to this. If we try to take this direction, if we try to unfold the thread, we will start from here, take this section and try to unfold this particular thing, then what will really happen? You will see that we are doing one full rotation. So this horizontal distance should be 2 pi small r, and what should be the vertical displacement? L, which we have defined like P to P and all that. So this is what it is, the total length of your thread. Okay, so this is how we try to find out the solution for the mechanics problem in the thread. So what will happen? You can, so for a given L and 2 pi r, let us say you know L, which is nothing but n p, and this is your 2 pi r. So you can find out tan theta is equal to L by 2 pi r, and theta is equal to tan inverse L by 2 pi r. Okay, now we have to solve this problem. So you will see that, let us try to first solve a problem in which you will have to raise the load on the above side. So this is your block. This block is having weight W or the load W, which is acting over here. It has to be raised up. It means that on this particular block you will have a reaction forces which is acting in this direction. So let us call this as F. And you will have normal which is acting in this direction, which is N. So you have the reaction force, normal, and W load. Now what you have to find out, you have to also apply a load to raise it up. So that particular, so what is important here is this will not be the load that will get transferred. So basically this will transfer the moment, and moment will transfer another load over here. What is that particular load? So that particular load, let us call it as F. Okay, so this F will be M by R. R is the radius of this, but what is M? PA. So M is PA, it means that this is equals to PA by R. Okay, so this is what is actually acting over here. Now if you try to draw the ability of this particular structure, you will see that, again, let me, so this is your normal, this is your particular thing. So this angle is your, what will be this angle? This angle is your theta angle, right? This particular angle will be your theta angle. Yes. Now, if you write down the equilibrium equation for this particular. So before like writing that, let me also put one thing that we discussed that when we have the normal forces acting like this and the reaction forces acting in this direction, sorry, friction forces acting in this direction, whether this is equal to this. And so resultant of this particular force can be written like R, and you will find that this is the angle theta that it makes with normal end, which is mu s. Okay, which it makes mu s. So what will really happen here is your theta s that you have found, tan theta s found is nothing but f by n. What is f? Mu s n by n, and this is nothing but mu s. Okay, so theta s is nothing but a tan mu s. So this is how you correlate the angle of the resultant with the normal with the coefficient of friction. If it is kinetic friction, similarly write m is equal to a tan mu. Okay. So assuming that in this case the resultant is this. Here is the resultant, which is R. So what will be this angle? This angle will be theta s. But you know that this is your angle which is theta. This angle is your theta from the thread you got, lead angle. This is your lead angle. And this is your friction angle. So in this way, if now you have to find out the force F which has to resist this particular. So the force F, writing down summation of, first of all, if you want, you can summation of Fy. So this will give you R cos theta plus theta s is equals minus W equals to 0. It means that your W will become resultant of R times theta plus theta s. So by the way, what is R? R is nothing but n square plus u square and square. So it means that this is 1 plus mu s square. The resultant is okay. So this way you can get this relation. Now if you write down the equilibrium forces along x direction, like this, you will see that this is your F minus R sine theta plus s, okay, equals to 0. Ultimately, you will see the relationship of this F. This F is nothing but P A by R, which is equals to R sine theta plus theta s, and this will give you the load P, which is nothing but capital R small r divided by A sine theta plus theta s. Okay. And what will be R? R is nothing but W by cos theta plus theta s. If you substitute this particular expression over here, you will get your Fs. Your Substitute R over here, so you will get P is equals to W R by A tan theta plus theta S, and this is your solution. Okay, so this is how you try to solve the friction problem in screws. Now let us take another application. Let us take another application, which is this is third application, in which we are going to talk about thrust field. We are going to talk about or collar field. So instead of solving this problem, let us try to solve some generalized kind of problem. For example, let us say the bearing has to take a axial load W, and it is also rotating with moment, and this is what is being applied. Moment M is applied. So this is your particular and you have this as theta, and these are the contact points. Okay, these are the contact points. Now find out the moment M such that it will give you find out the minimum value of moment M, which will which will overcome the frictional forces which are existing over here. So how to do this? First of all, you have load W, so you can apply. So, and let us take also the radius here is R1, okay, and radius here is R2. So in this case, if that is your theta, let us try to write down the forces over the contact region P. So first of all, you will see that what is the pressure which is distributed over the contact region. So if you see the pressure which is distributed over the contact region, so this is your contact region, this is your contact, your R1, this is your R2, and the load applied is like W. So the pressure which is distributed over here will be, which is nothing but W divided by pi R2 square minus R1 square, right? So this is how so what will be now using this particular relationship, try to find out the moment which is acting over here. Let us take the top view of this particular. First of all, take a small section over here. You will see that how your dn will be acting. Okay, dn which is normal, and reaction forces which are acting over here are the elemental ring that we are taking to find the problem R, and this is your. So basically have to find out this dn. Now if you look at the direction of your dn, what will be your friction forces? Friction forces along these directions, nothing but F will be mu times dn, right? And since this is the angle which is given as theta, so perpendicular to this and perpendicular to this, so this is your theta. Okay, this is how you will find your theta. Now you will have to find out your dn. So to find the dn, what you really have to do is you will have to equate this forces. So dn basically will be given by, so this particular component in the vertical direction, which is nothing but, where you will see your dn sine theta. So write down the equations which is written as f of y is equal to 0. So in this case you will see that dn sine theta minus w and sine theta minus w sine theta. So minus w. So what is the weight which is distributed all? But so this will be dw. dw associated with the weight which is distributed over. That is given by and sine theta, and this is w is nothing but w times pi r2 square minus r1 square. The area of this particular thing, 2 pi r into dir. 2 pi r and dr. So this is the total weight taken by this small ring element. So if you try to use this particular expression, you are going to get dn is equal to w. So let us take this part. You are going to divided by r2 square minus r1 square and sine theta, okay, and r dr. So it means that your dn is given by this particular. Now you have to find out the moment which has to be overcome, like required to overcome this friction. So what is the moment over here? The moment due to the friction will be given by r times df, but this is equal to times dn. But what is dn? There is this. So you will be having w s, right, divided by r2 square minus r1 square into sine theta, and you are having r there, so you will be having r, and find this total, you will have to simply so, and this has to be integrated from r. Getting total m is equals to w mu s divided by r2 square minus r1 square sine theta, okay, and this will be, so there will be r cube by 3. So here you will have 3 also. So here r2 plus r1 cube. This is what it is. So this will be divided by this. Let me write down again. This m that has to overcome this friction is nothing but w mu S divided by R2 square minus R1 square sin theta, and here R2 cube minus R1 cube. So the relationship of moment time required to work on the friction of this kind of. Now if you want to convert it into the end mass, it means that this portion will become, what will happen? This portion will become straight. If this portion becomes straight, what will happen to your, if you want to convert it into, let us say, want to convert it into a case where your theta becomes 90 degree, it means that this is there and this is there. So it means that when theta is 90 degree, it means that you will be having a case where this side similar to the case of theta. So in this case, what will be your M? So this is called the collar bearing. Collar bearing. In this case, what will happen? This expression will become W mu S R2 cube minus R1 cube divided by simply R2 square minus R1 square. Now if you want to discuss about the end one in which you had this case, so in this case R1 will become 0. This is the case where R1 will become 0. So our M will be equals to 2 by 3 W mu S R2. So this is one case, this is another case. So this is a generalized one. For the collar bearing, this is the moment that has to overcome, and for the end case, this is the moment that it has to overcome. And this is your R2. How you try to see the application of friction in the case of thrust bearing. Now let us try to see the application of this friction in journal bearing as well as the rolling resistance.